In this video, we consider yet another example on how to test hypotheses, and after that, we will look at how to determine sample sizes when we're conducting test of hypotheses on two population proportions. So we begin with the example here. We're to conduct the following test at alpha equals 0.10 level of significance by determining the null and alternative hypothesis, the test statistic, the p-value. We are to assume that the samples were obtained independently using simple random sampling. And this is a statement of what we want to test. We want to see if one population is significantly different from another. And the sample data collected from each of these populations are here provided. So, as it stands, we are ready to go. So the first step, I am going to split this just to manage my space here. And in this case, I would like to test to first verify my assumptions here. So verify assumptions. And those assumptions, A, is that we have what? Independent samples. Independent samples. And then the next one is that we check if N1, P1 bar at minus this guy, if it's at least 10. We also check if this is also true. This can, and then 3C, we check if the sample size of each of the samples we are selecting is no more than 5% of the population, of each of the populations. This can be verified at your own ease. Then in step 2, we're going to write out the null and the alternative hypothesis. To write the alternative hypothesis, what do we want to test? We want to test if the population proportion 1 is different from that of 2. So this would be the hypothesis of equality here. And at what level of significance are we testing this? This is alpha equals 0.10. Then the next step then is to find our test statistic. Step 4 would be our p-value. All right, so let's first find the test statistic. To do that, we're going to need x1 is 30 out of n1, which is 254. I'm getting that from the given question, versus x2, which is 38 out of 300 and n2, 301. Okay, so we're going to key this into StatCrunch and go to StatCrunch, go to this, statistics, proportion statistics, to sample with summary in this case. And in this case, so for the first sample, I have 30 out of 254, 30 out of 254. And then for the second example, I have 38 out of 301. 38 out of 301. 38 out of 301. And then for the alternative hypothesis, the right inequality should be not equal to. So that's already fixed. And I would like to conduct a hypothesis test. And I would like to show the critical value when the significance level is, let's go back, our significance level is 0.10. So I will set that correctly, 0.10, and compute. And here, let me drag this way. My test statistic is negative 0.29. So I'll take that back. Test statistic value. So the value of the test statistic is negative 0.29 based on what we got from StatCrunch. And then our p-value is 0.7709. So I'll put that up here, 0.7709. Before I continue, still on the test statistic, I'm going to draw my normal distribution. In this case, this is not equal to, which means it can be either less than or greater than. This is a two-tailed test. And the value here that cuts off those values are negative and positive for a two-tailed test. All right, so what am I going to do? I will go to my critical value. This is 1.645. So I have negative 1.645 here and positive 1.645 here. Then all I need to note is that my test statistic, negative 0.29, lies where? Is it in the rejection region, which is shaded, or otherwise? Negative 0.29 should be somewhere before negative 1.645. So it does not fall in the rejection region. So this tells me something. Conclusion. So based on the realization that our negative 0.29 does not fall in the rejection region, we also will not reject the null hypothesis. So if we're not rejecting the null hypothesis, it means it is the winner. And this alternative is the loser. In what sense has it lost? It means as far as our sample information is concerned, we do not have enough evidence, or there is insufficient evidence to conclude on the alternative hypothesis. With that said, we move on to another concept pertaining to how to test hypotheses about two population proportions. That is how to determine your sample size. When you have a given margin of error that you want to attain, we use this formula. Well, just in case you're wondering what that formula looks like, a quick example will quickly show you that it's actually relatable. Just note that the use of n here can stand for the sample size you're taking from either the first population or the second population. In other words, they will have the same sample size. Okay, in this example, a nutritionist wants to estimate the difference between the proportion of males and females who consume the USDA's recommended daily intake of calcium. What sample size should be obtained if she wishes the estimate to be within 3 percentage points with 95% confidence, assuming that A, she assumes that the results of the USDA's 1994-1996 Diet and Health Knowledge Survey, according to which 51.1% of males and 72.5% of females consume the USDA's recommended daily intake of calcium. And that will be the second question, but we'll get to that in a little bit. In this case, here are a couple of notes to note. There were previous estimates that were available. This will be our P1 at, which is 51.1%. 51.1 divided by 100 is 0.511. And P2 at is 75.2%, or 75.2 divided by 100, 0.752. Okay, so we have our P1, we have our P2 that we're going to need in the formula. What about E? E is the margin of error. In this case, we want to be within our wiggle point, or margin of error is within 3 percentage points. So error is 3 percentage, or 0.03. Then we need Z of alpha over 2. Okay, so our Z of alpha over 2 will be, we split. We want a 95% confidence, so 95% goes in the middle. And so we want the values here. We want the value here or here. So how do we do that? We go to StatCrunch. In StatCrunch, you go to calculators. Go to the normal calculator and choose between. You want the size of the area between to be 0.95 and compute. So this is 0.95 in the middle. Those cutoff points here are negative 1.96 or positive 1.96. Pick the positive one. So our Z of alpha over 2 is 1.96. 1.96, that is this value. And with that said, you have every ingredient you need in this formula. So it's time for plugging. So our N equals N1 or N2 will be 0.511 multiplied by 1 minus, I think I might need the space, minus 0.511 plus 0.5752 times 1 minus 0.752 multiplied by z of alpha over 2 is 1.96 divided by error. The error term E is 0.03 from the question. And don't forget the square. Many students usually forget that. Please note it. So this will be equal to, please note that there is a parenthesis here, which means that we must ensure that we first complete this calculation inside these brackets first. So multiply these two answers, multiply these two, add the answers together first. So when I did that, I got 0.436375. So I'm going to multiply this answer for all of what I have inside the brackets. I'm going to multiply it by, first, 1.96 divided by 0.03. I'll get the answer for that. I'll square it, get the answer, then multiply it by this guy. This should give, so when you multiply all of these calculations, you should get 1862.642. Please note, always round up. So this rounds up to 1863 subjects or people. All right, then for the second case, question B. What if she was not given P1 and she was not given P2 arts? That means she does not have any prior estimates. Yeah, no prior estimates were given. In such a case, you are required to set P1 to 0.5 and P2 also to 0.5. Both estimates must be set to 0.5. And so our error still stays the same. Our z of alpha over 2 still stays the same, 1.96. And let's see what happens. N equals, this time, 0.5, 1 minus 0.5. So 1 minus 0.5 plus 0.5, 1 minus 0.5. So you get all of that, multiply by 1.96 divided by 0.03, all square. So if you work on this, this is 0.5 times 0.5, 0.25 plus 0. Another 0.25, so you should get 0.5. So you have 0.5, then 1.96, all square. And this will be equal to 2134.222 and so on. Again, make sure you round up, regardless of this two. Make it 2135. Always round up. Right, that brings us to the end of that question.